So some curves reach their zeros and maximum R values at more than 1 point. And so let's try to sketch the graph R equals 2 cosine of 3 theta. So first of all, I know that it's cosine. And so let's say the symmetry, we know it's across the polar axis. Let's find our maximum R value. Our maximum value of R, absolute value of R. And so that is, again, when cosine of 3 theta equals 1. So 3 theta equals 1 when we were at 0, pi, 2 pi, and 3 pi. So I'm going to do a couple because what we're going to have to do next is to find theta is we have to divide by 3 to isolate the theta. So we notice now that the maximum values of R are going to be 0, pi over 3, 2 pi over 3, and 3 pi over 3 is just pi. And so what is that maximum value, so absolute value of R? So let's plug in 2 cosine of, let's just say 3 times 0. And so that's just going to be 1. So 2 times 1, so 3 times 0 first, so 2 cosine of 0. And so 2 times 1 is 2. So our max value is 2. Now let's look at our 0 of 3 theta. So 0 of R. So that is when 0 equals cosine of 3 theta. So 3 theta equals 0 at pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. Then now we have to divide by 3. So our zeros of R are going to be when theta equals pi over 6, and then pi over 2, 5 pi over 6, and 7 pi over 6. So again, that's going to help us out with the sketch a little bit more. And so for me, it's kind of like just a check. So I am going to still plug in values. And then I know that if I made a mistake, I'm like, oh, I should have a 0 there, or this should be the maximum here. And so that helps me in my sketch a lot more. So let's go ahead and plug in some values here. Let's just start at 0. So 2 cosine of 3 times 0. So we're really looking at cosine of 0, and we know that is 1. So at 0, we are at positive 2. Now let's check. Now if I were to check, I'm going to check pi over 6 here on this side because I already know what's going to happen. So let's try pi over 6. 2 cosine of 3 times pi over 6. So notice what happens here is I have to do this operation first. So really I'm looking at 2 cosine of pi over 2. And remember that pi over 2 is 0. So I'm looking at 0. Pi over 6, I'm at 0. So that doesn't really help me with the curve a little bit. And so sometimes you have to go a little bit less than pi over 6. So in this case, I really want to go to pi over 12 because if I get this point here, 0, 2, and then I get a 0 here right in the center, I want to know, well, where is this graph going? I mean, is it going this way? What's happening with it? So let's go ahead and plug in pi over 12. So 2 cosine of 3 times pi over 12. And then so we can reduce this. So we're really looking at 2 cosine of pi over 4. Now 2 times cosine of pi over 4, that's root 2 over 2. And so this is just the square root of 2, which is approximately about 1.4. So at pi over 12, I'm at 1.4, and so that helps me a little bit more about what's happening with my graph, right? So it started here, this is my first point at 2, then it goes here, and then I know that it's going to reflect eventually down here as well at the 23 pi over 12. Now let's choose another value. Let's try pi over 4. So 2 cosine of 3 times pi over 4. We're looking at 2 cosine at 3 pi over 4. So 3 pi over 4, we're going to get a negative value. We're going to get 2 times negative root 2 over 2. So we're looking at negative root 2, which is a negative 1.4. So again, to graph that negative, at pi over 4, we get a negative 1.4. So that's going to be here. Negative 1.4 is on this side, about right there. So this is what's happening to our curve on that side. Now let's choose another value. Let's choose pi over 3. Pi over 3, we know that's going to be a max value. It should be a max value of 2. So 2 cosine of 3 times pi over 3. Notice that cancels, and so we're looking at 2 cosine of pi. And so that is 2 times negative 1, which is a negative 2. So at pi over 3, we're at negative 2 right here. Now let's look at another value. Let's look at pi over 2. And actually, you should know what's happening at pi over 2. 2 cosine of 3 times pi over 2. So we're looking at 2 cosine of 3 pi over 2. And that is going to be 2 times 0, which is 0. And so what's back here in the center? And actually, since I know it's going to go to the center, I know it's going to hit through this point here. And then so I'm getting this shape here. It should be a little more curved. So let's choose another value. Let's go ahead and choose 2 pi over 3. So that's going to be 2 times cosine of 3 times 2 pi over 3. So we're looking at 2 cosine of 2 pi. And so that's 2 times 1, which is 2. So at 2 pi over 3, we're at positive 2 here. Then let's try another value, 3 pi over 4. So 2 cosine of 3 times 3 pi over 4. So that's 2 cosine of 9 pi over 4. And so that's about pi over 4. So 2 cosine of pi over 4, that's a positive root 2 over 2. And so we're looking at positive root 2, which is a 1.4. So again, that gives us another idea of what's happening with this curve. And so it's going in this direction here. And then one more point, we can see at 5 pi over 6, that should be at our 0, right? So it's a 0 of our r here. So if we plug that in, I'm running out of space, but 2 cosine of 3 times 5 pi over 6. That's 2 cosine of 5 pi over 2. And so that is going to be 0. And so it hits there at this point. And then it's going to continue through and finish this point here. And so we get this really cool picture. So I want you to try this out. Sketch the graph of r equals 2 sine of 3 theta. So you should have found the symmetry is at pi over 2, and then the max value of r is 2, and that is at pi over 6, pi over 2, 5 pi over 6, and 7 pi over 6. The 0 of r is when theta is pi over 0, pi over 3, 2 pi over 3, and pi, and then just plugging in a bunch of values in order to get the picture of this graph. Now, another good reason for knowing what your maximum value is that if you know it's 2 and we have 5 here, 1, 2, 3, 4, 5, you could extend it a little bit, right? So in this case, I did make this as a half and then 1 and then 2 here to kind of make the graph fit a little nicer. And so that's another reason to know your max values as well. And I could have done that with this other example too. So that is always an option for you.